In this lecture, I'd like to cover some of the main concepts in Chapter 2. And Chapter 2 is really about how to organize, describe, and display your data. Some of these concepts are really important, and some of the terms and definitions will be important because we'll build on those as we talk about particular statistical tests. So it's really important that you get some of these basics in the beginning of the semester. So first off, we've talked a little bit about this before, but what is a variable? And a variable is a characteristic that can and does assume different values for different people, objects, or even events being studied. And so we talked about independent and dependent variables in our studies, and you'll work on identifying some of those in some future assignments. And the way we measure variables is on 4 different measurement scales. So variables can be nominal, ordinal, interval, and ratio. And it's important that you can identify whether a variable is one of these 4 and which one it is. So we'll go through each scale. Nominal is basically, a number. There's no particular order, and the assignment of numbers to categories is arbitrary. So while a nominal variable we might code as 1, 2, 3, 4, there really isn't any numerical relationship between what we code as 1 and what we code as 4. And so examples of nominal variables might be gender. We might code male as 1 and female as 2, or ethnicity. And there really is no numeric relationship between male and female. We just code them as 1 and 2. And so that's a nominal variable. Ordinal variables represent categories that can be placed in some type of numeric order, so lowest to highest. We don't really know the size of the interval between the different values, so we might say 1, 2, 3, 4, but the space between 1 and 2 might be different than the space between 3 and 4, or we don't really know sort of that there's some value in between that. And so there's no true zero in an ordinal type of scale. So some examples of these would be a pain scale. So we may say 1 is no pain, 2 is a little pain, 3 is some pain, and 4 is a lot of pain. And there's a clear sort of pattern, like this is no pain, number 2 is a little bit more pain, 3 is greater, and 4 is the most. But we don't really know that 2 is double what no pain is. We don't know that a little pain is double what no pain is. And so a lot of these subjective scales are ordinal types of scales. So they can be sort of put in a value of least to greatest, but there isn't sort of a numerical or a true zero for these types of variables. Intervals. Interval scales are numbers that can be placed in meaningful orders. So all the intervals between the numbers are equal. You can add and subtract these. There is no true zero, so ratios can't be calculated. But some interval things might be Fahrenheit temperature, SAT scores, GRE scores. Any type of standardized testing scores would have some type of interval variable. And then ratio. So ratio scales, numbers can be put in a meaningful order. The intervals between the numbers are equal, and there is a true zero. So there is sort of something could measure a zero. Almost all of our biomedical measures, weight, pulse rate, cholesterol, are on ratio scales. So age, number of minutes spent exercising, cholesterol levels, number of weeks pregnant, all of these would be ratio. And so these do have a true zero. Sometimes it's a little bit tricky to pick which one, but we'll do some practicing of the different types of variables. So this sort of question test, what measurement level is the variable military rank? So let's say maybe our population was those in the military, and we wanted to know at what rank did they serve in the military, and we've asked them to fill out their different rank. I don't know all of them, but sergeant, corporal, those types of things. What measurement level would that be? So the answer is ordinal. Military rank doesn't have a true zero or equal intervals, but the categories can be put in order. So you move from a private to a corporal to a sergeant, and a master sergeant is sort of the highest level. So that would be an ordinal variable. If you chose nominal, that may be something that you considered. The reason it's not nominal is because there is sort of a ranking of the categories. Even though they're not equal intervals, you can sort of put them in a ranking order. Next, we're going to talk a little bit about displaying data. And sometimes we want to get a good sense of what does our overall data set look like, or the measure that we are doing look like. And so some of the measures that we might use would be central tendency, which is the most frequently occurring values, the dispersion, how the values are spread out, the shape and skewness, and that's the symmetry or asymmetry of the values and how they're distributed, and then outliers. So are there values that don't fit the pattern? So you have most of your scores fall nicely within a pattern, and then you have maybe one that sits way as an outlier. So here is a frequency distribution table. So for this data set, they asked people how much they weighed, and there was intervals. You could choose between 100 and 119 pounds, 120 and 139, and all these choices here. And then this would be how many people selected each session. So you can see the most number of people weighed between 180 and 199, so 11 people, but you can see how that is distributed. And then this relative frequency would be the percent of the total sample that chose that range. And then cumulatively, this just adds up to 100 here on the right side. Histograms are another way that we visualize data, and data have to be at least ordinal to use a histogram. And so in a histogram, the values of the variable are on the x-axis, and then class intervals are used. And the bars of the histogram kind of touch each other. So it's not kind of looking here, you can see this is also sort of how many. This is the same data set. We can see that, actually, this is a different data set, sorry. The weight here is on this x-axis, and then you can see that this is how many people fell within this range. There's 4 people that fell within this range. There were 7 people who chose 150. I'm guessing it's 175. There were 6 people. Maybe this is 175 to 200. This range, there was 10 people. And so this is a histogram. True or false, a histogram would be a good way to show a distribution of ethnicity among the participants of a study. So if we ask people what their ethnicity was, would a histogram be a good way to show that? The answer to that is false. Ethnicity is a nominal variable, and histograms are generally used for ordinal, interval, and ratio level variables. So a frequency table would be a better choice. So our previous one would be a better choice. This would be a better choice to demonstrate ethnicity, because it's a nominal value. Measures of central tendency. So overall, the goal is to get a feeling for what's the most frequently occurring value in your data set. These terms probably are familiar to you. The mode is the most frequently recurring value. So if there are, 7 people chose number 3, and that's the most, and so that would be our mode, would be number 3. The median is the value that's in the middle of the distribution. So the value at the 50th percentile. And so that sort of gives you that middle point. And then the mean is the average of the distribution. And you can see that generally mode and median are used for nominal, ordinal, interval, and ratio, like all types of data, mode and median. Mean is really only used for interval and ratio level data. Sometimes we use it for ordinal, but not very often. The mean, when it's calculated, looks like this. I'm not going to ask you to hand calculate these types of things, but basically you would add all of the values in a given data set and divide by the total number of values that you had. I'm sure you've calculated means or averages before. There's a measure of dispersion, and this is to get an idea of the spread of the data. So sort of what is the overall spread of the data? The first measure of dispersion is range, and then in the range is the difference between the highest and the lowest value. Interquartile range is the value that is in the middle of the distribution, so the value at the 50th percentile. And standard deviation is the average distance of each point from the mean. And so standard deviation is written as a plus or minus and then a number. And so that is the average distance of each point from the mean. And that's most appropriate for interval and ratio level data only. So here's how you would calculate the standard deviation. I'm not going to ask you to manually calculate the standard deviation, but that is the mathematical formula to do that. Skewness and symmetry. So sometimes when we look at our data graphed out, we want to see if there are sort of symmetrical distributions. Are the data evenly distributed around the center? Are the distributions normal or not normal? Which we'll go into a conversation about that as we go into some of the tests a little bit later. But is there basically the same amount of data on the right side and the left side of the distribution? So these distributions can be symmetrical or they can be skewed. And so skewed might be that data are not evenly distributed around the center, and they can be right skewed or left skewed. So you can see this would be a normal distribution. This is a rectangular distribution. This is a U-shaped distribution. And all of these, you can see that there's pretty much the same amount of data on the right and left sides. Here we have a right skewed and a left skewed data. And so we can see that this, instead of following a nice normal curve, this is skewed, is right skewed, and this is left skewed. So just knowing when you're sort of looking at the distribution of the data in a graph like this, is it a normal distribution or is it skewed? So what would be an appropriate measure of central tendency to use when looking at the height of children at age 5? Mode, median, mean, or all of these? The answer is D, all of these. Height is a ratio level variable. There's a true zero. So you could use any of those measures and maybe all of them when describing height. So this covers just some of the basics of chapter 2. It's really important to understand some of those terms: nominal, ordinal, ratio, and interval data, and to be able to identify those, and then getting an idea of how data is presented, because you will be doing some presenting of data and looking at distributions of data here in the near future.